Redback's exclusive 5-star certification addresses critical performance factors for cord strapping. Our weave patterns, coatings, and buckle geometry work together to provide some of the highest repeatable performance in the industry. We demonstrated this in a previous video where the system strength of our 1,830-pound strap with a 70% joint strength outperformed the system strengths of a leading competitor's 2,400 and 2,700-pound straps. And in our last video, we showed our 1 1/4 3,300-pound strap with more than 80% joint strength outperforming the same leading competitor's comparable system by almost 20%. So how is this possible? Where there is a difference between linear strength, joint strength, and system strength. Linear strength is end-to-end strength, and all straps can achieve a rated linear strength whether they are good strapping systems or not. They all look good on paper. Joint strength, on the other hand, is end-to-end strength with a fastener in the middle. It incorporates the joint efficiency of the strap and the buckle, which takes into consideration the dynamics of weave pattern, coating, and buckle geometry working together. System strength is the strapping in loop form with the buckle and is also theoretically twice the joint strength. For example, a 1,000-pound rated strap with an 800 or 80% joint has a system strength of 1,600 pounds. However, a 1,000-pound rated strap with a 40% joint only has a system strength of 800 pounds. That's a big difference in real performance. And when you have a 50% joint, linear strength and system strength are the same. Redback composite strapping systems typically achieve 80% joint strengths, and our woven strapping systems typically achieve 65 to 75% joints. Tying a basic overhand knot achieves a 50% joint. As the ends are pulled tight, the knot cuts down on itself, so any strapping system with less than 50% joint is problematic because the joint is either slipping or functioning more like a cutter than a fastener. We see a lot of strapping systems like this in the market. We'll show you some examples. Using our ASTM calibrated test machine with competitor recommended strapping and buckles in single wraps pulled in loop form at 5 inches per minute, here's competitor A slipping and breaking at the front of the buckle at 35%, 38%, and 42%. Now I want to point out that it's significant that most of the premature slipping and breaking we see occurs at the front leg of the buckle. So performing a double wrap, also known as a rail test, to lock the strap onto the back leg of the buckle does very little to improve performance. And testing a double wrap on the front leg of the buckle is for the most part meaningless because you can't tension a double wrap. Here is competitor A slipping and breaking at the front of the buckle at 43%, slipping and breaking at the back of the buckle at 35%, and then slipping at the back of the buckle at 40% and ultimately breaking at the front of the buckle. And here is competitor B, slipping at the front of the buckle at 44%, 46%, and 48%. Here is competitor C, slipping and breaking at the front of the buckle at 53%, back and front at 53%, and front at 44%. In our industry, people tend to use a particular strap because it's what they've always used. But few customers have sophisticated test equipment like we do, so they don't necessarily know what kind of performance they're really getting. They just think it works. But in our opinion, if a strapping system has low joint strength, it's not working, and there are likely more efficient and superior system strength alternatives available at a lower cost. If you would like us to test the strength of your strapping system or to learn more about Redback strapping in our exclusive 5-star certification, give us a call or check us out on the web at redback.com.